Good evening one and all, and welcome back for my 6th lesson, that is Bragg's equation. Bragg's equation speaks about Bragg's drive for action and interference. Suppose this is the crystal structure and these all are the individual atoms. I'll show you the individual atoms over the board with a small laser light. That is, these all are the individual atoms, let us suppose. And I'm focusing atoms over this, my structure, whatever I drew over the board. And suppose at this particular crystal structure, at a point, at an atom A, an X-ray is incident. It takes a diffracted path this way, and the same wavelength, with the same wavelength, an X-ray is landed at B and it takes a diffracted path this way. Suppose these all our atoms are separated by a distance which is a d spacing, and then the difference between two diffracted lights, rays, diffracted X-rays, is what is denoted as path difference. And according to Bragg's law, Bragg states that path difference is equal to L lambda. And he gave us one condition, that is condition on theta, at what incident angle you are focusing the X-ray on an atom. By changing the theta over there, we can get different peaks and different interference patterns. Then condition on theta for the constructive interference to be at its strongest, he says that. Then I just would like to bring it to you, your notice, that is constructive interference. When you go to a musical concert, there you will be able to listen to the music very nicely and you will be able to identify what kind of note it is and all, if you are a musician. Then that is what is called as a constructive interference. So many tablas and pianos, casios and a vocalist, so many people, one note into the other note will give us a beautiful, a kind of peaceful musical sense there. Suppose when we are going to a market to buy something, there are so many people talking around us, we cannot hear anything properly, that is destructive interference. So that is in sound waves. In light rays or in X-rays, if one peak gets into the other peak and one trough is going into the other crest, then this is what the resultant of it with a maximum amplitude, we will be getting the X-ray diffraction. Then in this, according to this, he says that 2d sin theta is equal to n lambda, and the path difference, as I already said you, that is AB according to basic vectors, that is AB plus BC minus AC dash is what is the path difference, that is equal to n lambda. But according to basic mathematics, AB is equal to BC, and then this becomes 2AB. 2AB it becomes. But AB is equal to BC according to trigonometric ratios, that is d by sin theta, and AC dash is equal to AC cos theta. Then AC is itself is again, AC is 2d by tan theta into cos theta. Then further simplification, 2d cos square by sin theta it gives us. Then when we are substituting these two values here, that gives us that is 2d by sin theta minus 2d sin square theta cos square theta by sin theta. But in these two terms, you have 2d by sin theta as common term. Then here 1 minus cos square theta, that's what I wrote over here, 2d by sin theta into 1 minus cos square theta. But basic trigonometric identities will tell us 1 minus cos square is sin square theta. Sin theta and square gets cancelled, 2d sin theta. And 2d sin theta is equal to L lambda is the derivation for Bragg's law, which is the condition for X-ray diffraction patterns. And in my next class, I would like to speak to you, how are we going to calculate the lattice parameters after getting the X-ray diffraction patterns. And thank you all, and we'll meet in my next class. Thank you.